Hello everyone, how is everyone doing? Today I am going to talk about cap theorem. The reason for me to talk about cap theorem is that it is so common to talk about that sometimes it gets counterintuitive to think about these three verticals: availability, consistency, and partition tolerance. So, a simple definition is that cap theorem indicates that you can realize only two of these properties at once. So, we'll consider all of these three things. So, first is consistency. The definition of consistency is very simple. That is, if you set a value to any of the nodes, you should be able to get the same value the next moment itself. Let's say in this case, if I write the value of x as 10 in this node, I should be able to get the same value from any of the nodes. Second is the availability. In the case of availability, if you try to get or read or write value from any of the nodes in a cluster, you should get a success response. It doesn't mean that you would try to connect to a faulted node and try to get the value, but if you try to get a value from the available node which is up and running, you should be able to get the response. The third is the partition tolerance. As the name suggests, if you have a cluster of nodes and the connectivity breaks down because of some Ethernet issue, some connectivity issue across the data centers, in those cases, these two nodes and these two nodes should be able to work independently. That is, now they will be work as if they are separate system. They might not be consistent or they might not be available, but they should definitely be able to work together. There is one small thing to remember is that in the world of distributed system, or there are so many databases which have been built in the last couple of years, the partition tolerant is something which is given, which is something which is there from day one. Because if you are thinking in terms of a scale, you must think that the connectivity can always break down. So modern databases always support the partition tolerant, and then it always gets consistency versus availability for the modern databases. Now we'll talk about the three verticals one by one by one. So till now we have talked about that the database cannot be always available, the database cannot always be consistent or cannot be partition tolerant. Then what it would be? So if something is not P, then it would be C and A. That is, if something is not partition tolerant, then definitely it would be available and consistent. If something is not consistent, then it would be available and partition tolerant. And if something is not available, then it would be consistent and partition tolerant. So if it is not one of the three, then it would be the remaining two. Here I have taken the example of MS SQL, MongoDB, and Apache Cassandra. All these databases are being heavily used across various companies and systems. Just one reminder that I am taking into the consideration the default behavior of all the three databases. Of course, they all come with some configurable properties to make them work a little bit of partition tolerant or consistent or make them available. But the example here taken are for the default behavior. So if we consider the example of MS SQL, so MS SQL is consistent and available. It is not partition tolerant by default. That is, at least it was not made partition tolerant in the beginning when it was there. It is a single node machine which is there, and something which is running on a single node need not think about the partition tolerant. Of course, it is consistent and all the relational database are always consistent, and it will be available. That is, if a particular machine is up, then you would definitely get the response. In the replicated world as well, what will happen is that you need to deal with the primary and secondary nodes, and if the primary node goes down, the client would need some intelligence to connect to the secondary nodes. And then it gets a little complex as well, because MS SQL was not meant for this purpose in the first place. Coming to the second one, that is the MongoDB. The MongoDB is consistent and partition tolerant, but it is not highly available. What do you mean by that? Because of course the data should be highly available. So it is not highly available because if the leader disconnects from the cluster, and a new leader is elected from the cluster, then the previous leader will become unavailable for the read and write. So here in Mongo, what happens is that it follows the single leader based system that have multiple replicas, and those replicas get the data using something called as OP logs. So there is one primary leader and there are secondary nodes. And if that primary leader has some problem in terms of connectivity within the cluster, or the client is unable to connect to the leader, here the leader is up and running and the other replicas are also up and running, but if you are not able to connect to them, then it becomes unavailable, because now a new leader will be set up and this will be marked as dead. So this is how the default nature of MongoDB is. The third is around the Cassandra database, that is, it is always available and partition tolerant. So the way Cassandra is set up is that there are multiple replicas of the same data, and then there are partitions as well. So you can define things like consistency level, replication factor, and quorum. So Cassandra has been made to scale from day one, but there is one small caveat that by default it is not consistent. You can set up the consistency level of Cassandra that is highly consistent, strongly consistent, etc. And by configuring the replication factor, that how many majority of the nodes you want to write before you give acknowledgement to the client. So things like these can be configured in Cassandra, but by default it says that you make a write request to a node and you give a success response. You do not wait for the replicas to give you ACK. So what would happen if the message gets lost? In those cases, you might lose the consistency part. There are tweaks, as I told, using which you can make the Cassandra consistent as well. But here we are talking about the default behavior. That's it from my side for today. Thank you everyone for watching the video. Till the next time, bye.